This is the 2015 question. That's a tailored polynomial. So part A, they want us to find the radius of convergence using the ratio test. So first thing we notice here is our general term, which is going to be used for the ratio test. So for part A, the limit as n goes to infinity of an plus 1 over an. So the first thing we're going to do is multiply or put n minus 1 everywhere there is an n. So negative 3, and this would be n minus 1 plus 1, so n over n plus 1, and then x to the n plus 1, and then we're going to multiply by the reciprocal. And then next thing we do is cancel everything we can. So notice there's going to be an extra 3 on top. It is positive because it's inside the absolute value. There is an extra x on top. Then we always ask ourselves, are the degrees equal? And they will be equal as long as it's not have a factorial. So this is equal to the ratio of the leading coefficients, which would be 3 times the absolute value of x. And remember, for the radius, for the ratio test to work, this has to be less than 1. So that tells us the radius of convergence is 3. Part B. Write the first 4 non-zero terms of f prime and express f prime as a rational function. So here is our f up here. So f prime would be 1 minus 3x plus 3 squared x squared. And I believe the next one would be minus 3 cubed x cubed. It didn't ask for the general term, but I can go ahead and do it because it'd be negative 3 to the n minus 1 times n x to the n minus 1 over n. Now, what do we know about this? This looks like a geometric series. So if I want to express f prime as a rational function, that would just be the geometric sum. So the sum would be a over 1 minus r. A is our first term. R is what we multiply to get to the next term. So it's going to be plus 3x. So there is our f prime. C says the first 4 terms of the series for e to the x. So let's go ahead and write that. So c e to the x is 1 plus x squared over 2 factorial plus x cubed over 3 factorial. And we need to multiply e to the x times f. So I'm going to take my e, and we're going to multiply it by the f. And remember, this series does go on forever. So then it would be x minus 3 halves x squared plus 3x cubed. And they want us to only find the degree 3 Taylor polynomial here. So imagine multiplying these out. Is there any way I can get a constant? Well, the only way I could get a constant is if I multiply a constant by a constant. I have a constant on the left side, but I don't over here. So there's no constant. So the next thing we look at is how many different ways we can get a linear. I think the only way I can get a linear is multiplying this 1 by this x. So my only linear is 1x. The next thing I'm going to look at is how many different ways can we get the x squared. So if I take 1 and multiply it by over here, we're going to get x squared. So that coefficient in front would be minus 3 halves. And if I multiply this x by this, I'm also going to get x squared. Its coefficient in front is 1. And then lastly, we're going to look at how many different ways we can get x cubed. So let's going back to our yellow. Let me get rid of some of this. So if I look at my yellow one, if I wanted x cubed, I'd have to multiply it all the way over there. So 3. Now our lime green, if I wanted x cubed, it has to multiply here. So minus 3 halves x cubed. And then lastly, this one right here times this one is going to give us x cubed, so plus 1/2. So that is our degree 3 Taylor polynomial for those things multiplied. So the scoring guidelines for this is Part A is worth 3 points. The first point will be from writing the ratio. The second point from finding the limit. The third point for finding the radius of convergence. The next one is also worth 3 points. 1 for finding the first 2 terms, 1 for finding the next 2 terms, and then 1 for finding the sum. The next one is also worth 3 points. 1 for writing the Taylor polynomial for e to the x, 1 for the first 2 terms being correct, and 1 for the last term being correct.